Let's study about factors affecting the resistance of a conductor and resistivity. Resistance of a conductor is its ability to oppose the flow of current through it. There are several factors affecting resistance of a conductor, such as length, area of cross-section, nature of material, temperature, etc. Effective length on resistance of a conductor. As the length of a conductor increases, resistance of that conductor also increases. That means, resistance is directly proportional to length. Effective area of cross-section on resistance of a conductor. As area of cross-section of a conductor increases, the resistance of a conductor decreases. So resistance of a conductor is inversely proportional to the area of cross-section of a conductor. Nature of material. Resistance offered by different materials is different, so resistance will vary according to the material used. For example, copper wire and iron wire of same thickness and length shows different resistance value. Effective temperature on resistance. As the temperature increases, the resistance of a conductor also increases. So temperature is directly proportional to the resistance of a conductor. Let's study about resistivity of a conductor. We know factors affecting resistance are nature of material, temperature, length of conductor, and area of cross-section. From we discussed earlier, resistance is directly proportional to length, and inversely proportional to area. Combine this together, so we can express it as resistance is proportional to length by area, that is, R proportional to L by A. To change proportionality sign, multiple with a constant, then R equals a constant into L by A. This constant is the resistivity of material, represented by Greek letter Rho. So the equation becomes R equals Rho into L by A. From this equation, we can find equation of resistivity as resistivity, Rho equals R into A by L. SI unit of resistivity is ohm meter. Definition of resistivity can be explained from the equation Rho equals R into A by L. If we take a conductor of unit length, that is L equals 1, and unit area of cross-section, that is A, equals 1. Then, Rho equals R into 1 by 1. That is, Rho equals R. From this we can understand, resistivity will be equal to resistance of a conductor, if its length and area of cross-section have unit value. Unit means value equals 1. So we can define resistivity as the resistance of a material of unit length and unit area of cross-section.